Let's do the pre-calc question first. If x is -2, what's your y value? Here's your -2, and what do you find? Does not exist. Boom. Now let's do the limit questions. -2 seems to be my important area. It's in red already, dashed, so that's where I'm headed. I'm not going to put it in blue for now. It's already where we want to go. So this says -2 from the left. So get on the train on the left side and follow the train to the red line. Goes to -infinity. Second one, -2 from the right. Get on the train just to the right of that line and ride the train until you approach -2, or positive infinity. And then therefore overall, one train goes that way, the other train goes that way. -infinity is way over here. Get on the train and ride it. Y equals 1. Positive infinity is way over here. Get on it, ride the train. Also 1. There's a little black dot down here, so be very careful on that one. Pre-calc question. If x is 2, a go to 2, there's that dashed line again, except there is a solid dot, so y equals -1. Now it's got the group of 3 together, where 2 is my important part. Once again, it's already dashed, so I won't worry about it. First one, get on the train from the left. Ride the train till you try and get to the red line. Goes to positive infinity. From the right, same thing, right? Since these two are the same, boom. Stuck, Brad?
A little bit.
Where at?
The first part, the f of 2 or whatever.
This one?
Yeah.
If I go to 2, I see, the only thing I see here is the,
Oh, it's just the point. Okay.
Just the
That's the point.
If that dot weren't there, would
then
it
it'd be like that one over the, like the first one would be does not exist.
Okay.
Okay, what if it was f of -2 then?
So then it'd be whatever that value is.
Do we just estimate them?
Yeah, but I'll probably give you one that works. -infinity. It's way over here. Get on the train. Goes to a y value of 0. Positive infinity goes to a y value of 0. Okay. Looks like it's a limit stuff, but it's a continuity question. All I'm asking is there any values of f of x that are not continuous? Any x's that blow this up?
1.
1. That blows it up?
Or the y value.
I want x's. What x's blow it up? 3 and
0.
it's discontinuous here at 0 and also 3. So we're not continuous at x equals 0 and 3. And then last but not least, are those any of those removable?
3.
Because it's a nice little circle right there, remember that open dot and something like that, that is a removable discount number.
Why is that though? Just because it's circled?
It's an open dot. Remember how basically what this would look like. If I got rid of one of those, if you remove them, then it'd be an open dot there. That's kind of what those look like. That other one, pretty straightforward one there, isn't it? Remember, use the original problem. Which two numbers blow it up? How do I decide removable? Factor them and cancel. Now here's the careful part. Which one did I just remove?
-3.
-3 is the one that made that 0, right? The 3 still makes this 0. So I didn't remove it, I removed the negatives. See these. All you're really thinking is, this number is going to go in there. If it's a limit question, you will see as x approaches 4. Because that's what's going on here. If it was 3, not really it's like a plug-in question. So most of the time you're going to see 4. So I'm going to take the 4, plug it in there. What do I get? -2. Then I'm going to take the 4 and plug it in here and I get 3. So the limit as x approaches 4.
Stays continuous at 4.
Well, the limit question first, it does not exist.
So those have to equal each other, right?
Yep, left side, right side, doing your fingers, that's all you're really doing. Then, in another sense, I might ask you a continuous question. Is f of x continuous? You would do the exact same thing I just did to answer the limit question, except it's not continuous. No, at x equals 4. Then the trig one. Any thoughts on the trig?
Negative sine cosine.
Sign in what? You want to do that?
Well,
Or does anybody else have anything else they'd like to try? Kevin wants to switch sine and cosine, which is alright.
tangent over x is 1 and sine x over x is 1 too.
Okay.
All we need to do is
So can we use that?
Breaking part.
break them.
Okay. So if you're going to use the tangent of x over x and the sine of x over x, there's one that's fine. Yes.
Okay, so when you separate it though, do you put 3 over 1, like by itself?
Yep.
Okay.
Because this part and that part are really gone. They're 1. And all you're left with is the limit as x approaches 0, 3. Anybody have any thoughts?
The cosecant x is 1 over sine,
Okay.
and then 1 over sine times x is x over sine x, and that's 1.
So you want to switch this to 1 over sine of x, is that what I see? And then so this is really x over sine x, which we said is really the same as sine x over x. So all of this goes to 1. And so all you really have is the limit as x approaches 0 of 5x squared. Is that doable?
Well, it is.
I just plug in and I get